This is going to be part 3 of a rational functions discussion. I'm taking a little bit more advanced level rational functions in order to clarify how to find the 6 pieces of information that we use to actually graph this. I have some brief explanations of our information for our asymptotes, intercepts, and domain and range. And along with those 6 pieces and some test points, I'm going to graph this rational function over here. Now this rational function is f of x equals x minus 1 divided by x squared. And I'll have to go ahead and find these 6 pieces of information in order to graph this without a calculator. First thing I'm going to find, of course, is the vertical asymptote. The vertical asymptote, as I have written over here, is the zeros of the denominator. And the zeros of this denominator is just whatever x I plug in to make it 0. And this one's actually pretty easy. It's just 0. And so my vertical asymptote is going to occur at x equals 0. My horizontal asymptote I find by looking at the degrees of the top and the bottom of the function and using my if-then statements. Well, the degree of the top is just 1. And when I talk about the degree, I'm talking about the exponent, or the largest exponent in the numerator, which is still just 1. And the degree of the bottom, which is 2. And so the degree of the top is smaller than the degree of the bottom. And if the top is smaller than the bottom, then my horizontal asymptote is y equals 0. My x-intercept, now this is something new from parts 1 and 2. My x-intercept, we actually are going to have some, is the zeros in the numerator. And in order to have zeros in the numerator, we need some kind of variable, and this time we do. We have x minus 1 in the numerator, so I want to find the 0 of the numerator. I'm finding out which x, when I plug into it, makes the numerator 0. In this case, that is only one number, that is x equals 1. But with an intercept, I'd like to write this in coordinate point form, so my x-intercept of 1 will be written as 1, 0. Looking at my y-intercept, my y-intercept is by finding f of 0, or in other words, if I'm wanting to find f of 0, I'm plugging a 0 into x and then simplifying. So I'm putting in a 0 into the top to make it 0 minus 1, and the bottom for 0 squared. Simplifying, that gives me the fraction -1 divided by 0. Now you cannot divide by 0. This makes it undefined. And what this does is just tells me that there are no y-intercepts. That's something different from parts 1 and 2. But we have no y-intercepts. And that came from being undefined in that fraction. Domain and range hasn't really changed much. Domain's still just x contained in all real numbers, except x not equal to our vertical asymptote, which is 0. Range is y contained in all real numbers, except y not equal to our horizontal asymptote, which is 0. So I found the 6 preliminary pieces of information I need to actually graph this, and I'm going to go ahead and graph what I have so far. So what I have so far is I have a vertical asymptote at x equals 0, which I'll do in green. And a horizontal asymptote at y equals 0, which I'll also do in green. From there, I'll go ahead and plot my intercepts. I only have one intercept. I have one x-intercept, and it happens at 1, 0. And right now, some flags should be going up. I have a point right now on top of a asymptote. You should be asking yourself, well, what does that mean? Because we have never had a point on top of an asymptote. In fact, you thought you couldn't have a point on top of the asymptote. So we got to figure out, what does that mean? Well, let me show you what that means. Starting from below, we still have this vertical asymptote, which means it's still going to approach this y-axis from below. But the fact that we have an intercept, and knowing what an intercept is, it does mean that it has to cross the x-axis at that point. But again, we have another asymptote horizontally. It will have to go back to approaching 0. So here's what's going to happen. It's going to make a little hump. It is going to cross the x-axis, and that just kind of describes what is an asymptote. Well, an asymptote is really just describing end behavior. It doesn't necessarily mean that you can't have it inside and in the middle of the function. It's just what's happening on the right end, the left end, the bottom, or the top. But in the middle, it can still cross it. It can still touch it. But this is describing the end behavior. So it will go up. It will cross the x-axis. It'll go up for a little bit, and then it'll come back down, and so it starts going through that horizontal asymptote again. It'll never touch that horizontal asymptote after this point. And so you should get a red flag when that happens. After that, there's really only one side I need to look at, and that is the left side. I need to figure out if my function is going to be here at the top, or if my function is going to occur at the bottom. And I do that using a test point. And my test point over here needs to be something to the left of the y-axis. I'll use something easy like -1. And if I put in -1 into the function, if it is positive, I know my function is occurring up top. If it's negative, I know my function is going to occur on the bottom. So let me go ahead and find out my test point. Let's see, f of -1 is what I'm solving for. I plug in -1 into x and simplify. Well, at the very top, that's -1 minus 1, which would give me -2. On the bottom, -1 squared. I notice I do have parentheses around that -1, and that would be 1, which tells me that f of -1 is -2. And this lets me know that the function does occur on the bottom. It's going to occur below the x-axis. So I'll go ahead and finish this off. And there I have now graphed the function. Let me go ahead and answer some questions. So first, some questions over just how you find any of the asymptotes, any intercepts, or the domain and range. Questions on how I graph the asymptotes, the intercepts, or the domain and range. All right, so this is kind of the new thing. Is there any questions on how I got this little hump? Yes?
It's not a question about that. It's like, you know how we did yesterday, like we had we did the range different. When we do that, like you know how you put it's like y is contained auto numbers, so y cannot equal parentheses 0 and -3 with the bracket. Will we write our range different when you give us a graph like that?
So the question is,
has that point?
Are we going to write the range differently? Because we did have the range as y not contained all real numbers except for y equals 0. But we do know that this thing crosses, so actually that's a good point. Now that we know that there is a little hump right here, and we couldn't really figure that out until we graphed it, we do need to amend the range. And so this whole y does not equal 0 thing is not true. It's a very excellent question. So it is just y is contained in all real numbers. In fact, this function hits all, actually, we do need to amend this a little bit. It doesn't actually hit all real numbers because it does not hit anything above. The question then becomes is, how high does this hump go? And as this kind of series of rational functions is geared towards pre-cal, that's a question that's going to either have to look at a table of values, which we do not have if we don't have a calculator, or it's going to use what's called a derivative test, which we do not know in pre-cal. And so I'll amend this and say, we'll go ahead and write it as y is contained in all known numbers except y above, we'll call it y above the hump. Because unfortunately, we do not know how high that hump is in the pre-cal setting. Next year, you will find out a way to do this. But this year, we do not know how big that is. Any other general questions over this problem? All right, I'm going to go ahead and erase this and put up the next problem. This next problem is going to be changed a little bit differently as well. I'm going to go ahead and draw my graph. And this next problem I'm going to take from number 5 out of your packet. And number 5 out of your packet is the function f of x equals x squared minus 1 divided by x squared minus 6, or minus x minus 6. Now, for this function, before I kind of go into finding all my asymptotes, all my intercepts, my domain and range, I need to really go ahead and factor out this function. Why? Because we're going to be finding zeros in the numerator and the denominator. If I want to find zeros of anything, I need to know the factors in this function. So let me go ahead and factor out this function real quick. Let's see, we got f of x equals to, on my top, in my numerator, that is a pattern I do want you to memorize. I have required you to remember that or learn this before. That is a difference of squares. The pattern that it factors to would be x plus 1, x minus 1. And we're divided by the factored polynomial on the bottom. Factored polynomial at the bottom looks like my factors would be x plus 2 and x minus 3. And putting it into factored form rather than standard form is going to allow me to find the asymptotes. It's going to allow me to find the x-intercepts a little bit easier. So I'll go ahead and go start with the vertical asymptote. Again, the vertical asymptote is the zeros of the denominator. If I'm finding the zeros of the denominator, it looks like it's at -2 and +3. So that is x equals -2 and +3. My horizontal asymptote is the big change right here. So let me draw your attention to this. We have not had a horizontal asymptote that's been anything but y equals 0. It's going to change right now. Again, I am comparing the degrees. If I look at the degree of the numerator and the degree of the denominator, I notice they're exactly the same. They're both 2. Because I'm looking at, the powers, the exponents. They're both x squared on top, x squared on the bottom. Those are the largest powers. And when they are both the same, that the top is equal to the bottom, then we divide the leading coefficients. I will go ahead and mark where the leading coefficients would be if they are there. Since there's nothing in front of the x's, we always assume that there's a 1 in front. If there's a 1 in front of both, that means 1 divided by 1, which is equal to 1. Thus, our horizontal asymptote is at y equals 1. It's the leading coefficients being divided. So that's the big change. X-intercepts, we're still looking at the zeros of the numerator. We already got it in factored form, so we can already tell that the zeros of the numerator occur at -1 and +1. But I want to put that into coordinate point form. And so that would be 1, 0 and -1, 0. This means that we have 2 x-intercepts. My y-intercept, I need to find f of 0. So we're going to find f of 0 by plugging in a 0 into x. On top, that's 0 squared minus 1. On bottom, that's 0 squared minus 0 minus 6. Simplifying on top and bottom, looks like -1 over -6, which is just 1/6 simplified. So our y-intercept is 0, 1/6. And if you kind of recognize a pattern with this already, good for you. When you're doing the y-intercept, really the only thing you're really comparing is the numbers that do not have an x next to it. The -1 and the -6 would be numbers that do not have an x next to it. Those are the ones you're really just dividing. Kind of make it easy on you. Domain and range, we'll go back now with x contained and all real numbers except x not equal to -2 and 3. And then y contained and all real numbers except y not equal to 1. So we have all of our information. The only thing we don't have is test points, but we don't know if we need test points quite yet. I'm going to go ahead and plug what I do know into the graph though. Let's see. I know my vertical asymptotes are at -2 and +3. And I know I have a horizontal asymptote at y equals 1. From here, I'll go ahead and put my intercepts in. Let's see, I have an x-intercept at 1, 0, and at -1, 0. And I have a y-intercept at 0, 1, 6. Well, what those 3 points right there tell me is that I have a parabola inside that's going down. So, using my asymptotes as a guide, a parabola should look something like that. What it doesn't tell me is what's happening to the left and what's happening to the right. And for that, I'm going to need some test points. Now the test points are actually pretty easy beforehand. We would say I would take this x value right here. If it was positive, I knew it was going to occur up here. If it was negative, I knew it was going to occur down here. But that can't be true anymore. When I choose this test point, let's say I choose x equals 4. If I get anything between 0 and 1, I know it's still below, because it has to be below this asymptote. If I get anything above 1, I know it's going to be above. So we will actually have to find at least relatively what the decimal value of it is. Well, let's go ahead and try this. I'm going to use a test point of, let's say 1, 2, 3, 4. Let's try f of 4. I'll plug a 4 into my function, which would be 4 squared minus 1 over 4 squared minus 4 minus 6. Looks up like on top I have 15, and on bottom 6. Now, like I said before, just the fact that it was positive, we would say, well, it has to be above. Not anymore, because if it's anything between right here, between 0 and 1, it would occur below the asymptote. But looking at this, just roughly, without a calculator, I can tell this is at least going to be 2 points something, because 6 times 2 is 12, and 6 times 3 is 18, so it's going to be between 2 and 3. Thus, I know it's going to occur above this asymptote, so I know it will be above. But I would suggest being careful with that, just making sure it is actually above the asymptote. Same thing over here. I need to test my next point, which I'll just go ahead and use f of -3, because it's to the left of the asymptotes. Again, it must be above the 1 or below the 1 for us to tell where it's going to be at. So let's see, f of -3. And since I'm dealing with a negative number, I am going to use a lot of parentheses. So let's see, -3 squared minus 1 over -3 squared minus parentheses -3 minus 6. Make sure you're using those parentheses correctly in order to help you find out PIMDAS. Let's see, at the top, it looks like 9 minus 1, which would be 8. At the bottom, it looks like 9 plus 3, which is 12, minus 6, which is 6 again. And just roughly, that looks like it's going to be like 1 point something. I know it's between 1 and 2, which tells me I do know it's above, and so I can go ahead and draw this function out. So the question was, do we know it's above because it's a positive number? And no longer can I say just because it's positive is it above. Because I could have a positive 0.3, but it would be below the asymptote. The fact that it has to be above the asymptote. My asymptote is at y equals 1, so the fact that it's 1 point something, which means it's larger than 1, tells me it's above. Can I answer any other questions on this problem now? All right, I'd like to point out something also new that's going to occur. And I don't have a function on hand for me to show this, but I'd like to point out something else that has not happened yet that will be happening on this page. What worked really well with that problem was that we were able to tell that it was a parabola inside just based on the intercepts. And so I'm going to go ahead and create some intercept or some asymptotes that kind of looks like my last problem. See, I'll create something like this, like that, and like that. And let's say I'll go ahead and use my test points, and I find out that on the right side my function looks like that. On the left side my function, let's say, looks like this. And on the inside, I don't know what it's going to look like. Let's say maybe I have a intercept right here in the middle. I know my x and y intercept are right in the middle. And we have two questions. Is this a parabola that's going up? Is this a parabola that's going down? Or does this look like an x cubed function? So I'm going to draw all the possibilities. It could look like this. It could look like this. Or it could look like this. Those are the three possibilities of what can happen inside. So here is what you'll have to do. And this is again another set of test points. You'll have to pick a test point over here to the right, see if it's positive or negative, so you can see which way the right side's going. A test point to the left, see if it's positive or negative, see where the left side is going. You know, if it's positive, this thing will be going up on the right side. If it's negative, on the left side it'll be going down, or on the right side it'll be going down. But you will have to use test points to the left and to the right of the origin. Questions on that? Yes?
Does it matter on which side of the applicable is? Like for that one, the applicable is for the I is for the or after?
It's a very good question. She has a, does it matter on what side the asymptote it is? And it does when you're talking about what's happening inside. When you're talking about inside, I want to pick an x value that's between the origin and the next asymptote. Now, what does not matter is if they cross this horizontal asymptote. That does not matter. They can cross that just like they did in the very first problem. But it's a very good question. Can I answer any other questions on this kind of middle behavior?
But it'll only cross, it would be horizontal asymptote if there's an x-intercept or not?
That might be some of that valid view. If there, it only crosses if there's an x-intercept. Well, no, because it could have a downward parabola, so it would never cross, even though it has an x-intercept. But essentially, you just got to remember, there's only three things that it could look like. It can either look like that. Oops, I'm sorry. It can either look like that, like this, or like this. And you just have to do test points on both sides to figure out which way they're going. Any other questions? All right, that concludes rational functions.